In this video, I will show you how to create the surface and the spots in the Emaris. Let's suppose there are two channels here. Let's suppose this is a DAPI channel or something like cell nucleus stain channel. This is the antibody you are interested in. Staining antibody. So the aim is to create a surface object for the antibody and a DAPI object for this DAPI channel. So click the surface, it will show surfaces 1. And surfaces 1, let's default click this next step. So from the channel you select which channel is the antibody you stained. So this antibody channel, and for the smooth you use the default. Just use the default is okay, and click next. So let's hide the DAPI channel. So this threshold is most important because if the threshold is too high, too much less is selected. If the threshold is too low, too more volume, too more is selected. So adjust that the surface covers the part of the signal. So when you use appropriate threshold, the surface will cover essentially all the part of the signals. So you may tick this surface untick. You can see the contrast. Say, do not use auto because the auto is very weird. Just drag and find the select, and it's 65 about. Next step. This is a filter. It can filter the very small dots so that usually is a number of voxels. There is always default filter. So you drag this. The red is the most largest part, and the left is the most smallest part. Usually you can keep you can discard the very tiny one if you like, and you can use a threshold. You can see how much threshold is okay to get rid of this small tiny object. For example, you input 100. Okay, you can click the tiny one. Or if you do not want to click, you can just click the delete. But it is better to click some tiny one because this tiny one may cause a lot of calculation burden in the later data extraction. Well, let's click next. Okay, this is done. So the surface is created. You can have a look at the surface. So very simple process. So for this antibody, because for this experiment, we can look at this data store parameters. We can store the parameters as antibody 1, experiment 1, or anything. Experiment is antibody A beta. Okay. So that this parameter is stored and you can reuse next time. Okay, let's continue with DAPI. You click the spots and next you select which channel is a DAPI nucleus staining, this one. And do not click background subtraction. Do not untick this. And this is estimate diameter. Estimate diameter. This is a constant for all the cells. For example, this green one is a DAPI. You can measure. You need just to do this once only. No need to do more. It's a 5.4 micrometer. This is 477. So it's roughly about 5. So the XY diameter is 5. Okay, next step. Next step, you use the quality. You do not. The default is always the quality above threshold. So that you say if the quality threshold is too low, some error, error will take place. This is erroneously treated as the DAPI. This is not good. So you drag to right side to get rid of this weird DAPI spots, but keep all the real DAPI spots. Okay, this is about 11. So you have a rough estimation of the threshold values. And next, okay, that's done. That's all. Then just click save. That's all. That's all what you need to do for each files. And for the sports one, we also want to save. Click the save store parameters. Experiment 1 nucleus. Okay, after this save, we close these files. Oh yes, save. Next, we open another one. Open the next image to process. Okay, next is similar to the previous one. So we use a surface. For this surface, we can from the drop-down list, we already have the stored one, experiment 1 A beta. So you just select this one, and if you select this one, then in the next steps, all the setting is the same as the previous one, as the first image. So you just no need to select this cell wall. It's already this, and the smooth is very similar with it's similar to the first example. So you just click next, and the threshold. The important thing is that the threshold is also reused last time, 65.7. But if you think this is not appropriate for the next image, you can manually adjust a little bit to make it more fit. Then you can just click this next, or you can also just click the double arrow, so you can directly all the way go to the end of the step. If you for this is the same, because usually we do not modify this step. So you can just you can just click the green button to go all the way down. And for the DAPI is the same. DAPI 的话， we click the experiment 1 nucleus we created, and you say it's the same. There is no tick for the background subtraction, and there is a 5 micrometer. So you click next, and the threshold is a quality threshold. It's 11.8. Is a reuse the demo one. If you think it is not appropriate, you may need to adjust a little bit to make it appropriate. Then click all the way down. Okay, then you save. So that's what all you need to do for this image files. You do not need to look at this data complicated, or no need to worry about this. You just create and save. And take note that the name must be services 1 and sports 1. If you delete this, if you think, oh, I make a mistake and delete this, and delete, and you create a second one, the name is services 2. It's changed. So you need to double click and make it services 1. And note there is a space between the services and 1. And you need to also make note that services 1 should be above the sports 1. And a sports 1 also name must be sports 1. So you just use the default, and the number should be 1. If you accidentally delete and recreate a 1, or delete this sports 2, you need to rename to sports 1. And then again with this nucleus. And save. So that's all. So the next thing is about for each experiment, because each experiment the antibody is different. So you need to if you for the next experiment the antibody is different, and if you want to reuse the experiment 1 A bit, it may be may not be good, because the channel may be different in another experiment. So you need to you better start from the default, and you do this for your new experiment to one file, and after that you save as experiment 2. After all the process is done, you store parameters experiment 2 amyloid AMY antibody. Okay, so for the secondary experiment you can reuse. So I think the threshold adjustment may be because there are variations between the images, and there may be more variations between your different clones. So that's why you need to manually adjust the threshold. And for the dead response, it's also you need to recreate a method and redo a new file and store, because the DAPI channel may be also different. For example, some files the DAPI is in the first channel, some files the DAPI is in the second channel. So these are recorded, also recorded in this list. So you need to do that. And if you want to modify the surface, for example, if you create this surface, I think, oh, I made a mistake, I need to go back. You can either delete and recreate, or you can just click the rebuild button. Rebuild. The rebuild is exactly the same, and you can just click next. If you click the rebuild, it goes the same process as what you used before for this. And you click then next, and you may adjust the threshold more precisely if you found that the threshold is not okay for this file. So this is a rebuild and correct process. So next is about the list files, list in the files. For example, you have 7 or 10 or 12 files on the because open each file takes time. So if you click one image file and it takes about 10 seconds to 15 seconds, and you need to wait. And after the process and the save, and you need to turn on the next. So if you found the takes too much time in the waiting, there is a way to open, for example, open 7 or open 10 files sequentially. And after all the files is opened, then you click these files and create, save, close, then switch to next files, then create, and save. So how can this be done? This is use a script. Okay. Here I will show you how to open, for example, 7 or 5 or 10 image files sequentially. Because if you think open one file and process one file, save and open another, there is a lot of gap time to waiting for open. There is a way to open several files at once, but you cannot multiple select and press the enter button to open them all. This is not feasible because Emaris has a authority check process in the beginning of every files. So every time it can only one files, and the check after it's cleared, then the files is opened. And if you select multiple files and press enters, before the first image is open and cleared, the second image is already trying to open, and then followed by the third. This will get stuck, and all the rest files will not get authorized, and all the open will be failure. So that's why it is not feasible to select multiple files and press enter to open them one by one. This is not unlike some music files or document files or your PDF files. No, Emaris is not like them. So for Emaris, the open of the files must be gapped. There must be sufficient time gap between the files. And this gap is dependent on the size of the files. If the file size is small, it opens faster, and the gap time is less, so you wait less time for the next time to open the next files. So to automate this, to simulate this process, this is a simple script to do this. So let me explain. So clip is clipboard paste. This is gets the file list from the clipboard. So first let's sample. Let's select 5 of 10 if you like, and press copy long path. Copy long path. What is copy long path? For copy long path, you paste is like this. So you copy all the file paths. Each file is one row in your clipboard. So after you execute, let me clear all the files. After you run this line, I press F9 to run this line. So what's clip? Clip is this, all the file list you are going to open. Okay. Next, I'm split this string by the chart 10 is a new line 10. I get a cell. So what's a cell? So cell is a 5 element. Each element is the path to image files. Next, I will for each file, from 1 to the length of the cell is 5. I will do for each file. I will do things. First is a Windows open one of the file, one of the image file. Then pause means wait for 5 seconds. Then next go on. So if I run this is what it happens. I press run. Okay, now it opens 5, the first one, and it wait for 1, 2, 3, 4, 5, 7, 5. Okay, we open the second. Wait 1, 2, 3, 4, 5. Open the third. After open it start to wait 1, 2, 3, 4, 5. Open the next 1, 2, 3, 4, 5. Open the next 1, 2, 3, 4, 5. So the gap between the gate open is 5 seconds. So in this way you can so in this way you can open 5 files, and during this process you do not need to sit on the computer. You can grab a coffee to drink, or you can watch a movie or something like that. So and this 5 seconds is only for them. You may need to change this time, because if for the larger files you need longer time. So you just manually open one file, and you estimate how long does it take to completely show the image. If it takes 10 seconds, you can set this a little bit more. For example, set 12, so that you know that. And how many files can you image at in one shot? This depends on the price of your computer, the hardware configuration of your computer. For my laptop, for this size, I can open 20 at most. And for your laptop, PC, you may, and depends on the file size and the computer, because your computer is much better than my laptop, but your files is also much larger than this. So it is a balance. So you can try 10 first. If you think it is okay, you can try 7, try 15, and you can gradually increase. Because after you create more and more images, you may find the computer is responding. It's maybe the computer performance may gradually drop. So then you stop at that number. And if you schedule too much numbers in the latter part, the authorization step may be stacked, and all the rest of the files they open will be filled. So you know that this is a lesson. So you set the number to a lower one. So it's very simple, right? Okay. I will finish the recording.